Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class we are going to discuss the topic an overview of center of gravity. Let's go to the topic. Center of gravity, the point through which the whole weight of the body acts irrespective of its position is known as center of gravity. That means the point where the whole mass of the object is going to be concentrated, that we will say a center of mass. Same, the point through which the whole weight of the body will act irrespective of its position is known as center of gravity. Okay, centroid, that is the plane figures such as a rectangle, circle, triangle, even the solids has only areas but no mass. So the center of such figures is known as centroid. Okay, so the center of gravity or centroid, these two terms are inversely that means used. Okay, sometimes instead of center of gravity, centroid will be used. Centroid, center of gravity will be used. Here, the rectangle, that means the center of gravity or centroid, formulas for the plane figures and solids we are going to discuss. The rectangle, consider a rectangle which has the width B and then the depth D. Okay, here we are going to consider B is the width of the rectangle, D, that is the depth of the rectangle. Then area of the rectangle, A, that will be B multiplied with D. And then the center of gravity, here I'm going to consider as X bar and Y bar. The center of gravity of the rectangle, that will be here. Okay, because it is symmetry about both the axes, that is XX and YY axis. Okay, and we know that the reference line, the bottommost line as the reference for Y bar. Okay, so this is a reference of Y bar. This leftmost line, that is the reference of X bar. Okay, so here the X bar, that will be the distance from the reference line to the center of gravity, that is this distance. Okay, this is actually X bar. Same way, this one, the vertical distance, that is actually Y bar from the reference line to the CG. So here you can see the X bar, that is half of the width, Y bar half of the depth. Okay, so X bar half of the width, that is B by 2, Y bar, that is half of the depth, D by 2. These formulas will be used in the numerical. Okay, rectangle, the center of gravity will be at its center where XX and YY axis passes through it. Bottom line as the reference line for Y bar. Leftmost line, that is the reference line for X bar. The distance of center of gravity from the reference line, that is X bar, that will be half of the distance B by 2, half of the width. Y bar, that will be D by 2, okay, half of the depth. Next, we are going to discuss circle. Its center of gravity will be here. Okay, at its center. So here X bar or Y bar, whatever, that will be radius. Here R is the radius of the circle. The leftmost line or leftmost point means this we will take. This is a reference of Y bar. This one, sorry, bottommost line for a reference of Y bar. The leftmost point or leftmost line, that is reference of x bar. So from this will be x bar here, and this vertical, that will be y bar here, whatever that is radius here. Okay. And then we know that area of the circle, that is pi r square in terms of radius, or if it is given in terms of diameter, pi by 4 d square. Okay. X bar, y bar, everything radius here. That is for the circle. Then for the triangle, which has the width b and then the height h. Okay. Here, two types of triangle we are going to consider. This one, it's like a equilateral triangle or isosceles triangle. It is symmetry about the vertical axis. Okay. But this type of right angle triangle, it's not symmetry about any axis. Okay. X axis or Y axis, it's not symmetry. Okay. So for this two, we are going to consider. Actually, area of the triangle in both the cases same. Area, that is half multiplied with b multiplied with h. This one width, and this one, that is height. Okay. So half into base into height. Then the center of gravity of the rectangle. Here, as usual, this will take the left bottommost line. That is the reference axis of y bar. Here, there is no line. So this one, or the point, that is the reference of x bar calculation. And here the x bar, like the symmetry triangle, equilateral triangle or isosceles triangle, which is symmetry about the vertical axis. Here you can see from the leftmost line, this is the reference line. From the leftmost line, the center of gravity will lie on this axis. It may be here, 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 wherever. Okay. But the distance from the reference axis, that is the leftmost line, or leftmost line passes through the, or line passes through the leftmost point. From that distance, the x bar, okay, that will be here b by 2. Okay, x bar, that will be half of the width or base. To y bar, for this case, from this we are going to consider. Actually, guys, this y bar, you can say, that means from here, that means from this vertex or from the base. Here, which side is the larger side? That we have to consider. This y bar is actually, we can say, I just write the note here, that is 1 by 3, the distance from larger end. Okay, 1 by 3, the distance from larger end, or 2 by 3, the distance from smaller end. Okay, 1 by 3, the distance from larger end, or 2 by 3, the distance from smaller end. Okay. Here, when I am taking the y bar from the larger end, because this is the larger end here. This one is smaller end. For this is smaller end. This one, okay, this one larger end. Okay. So here we are going to measure the y bar from larger end. Okay, that will be 1 by 3, the distance. That means the vertical height. That is h. So we can say the y bar is 1 by 3 h. Okay, for this type of equilateral triangle or the isosceles triangle, which is symmetry about any one of the axes. Then this type of right angle triangle, it's not symmetry about any axis. Here area same, no issue with the area. Only the change is x bar and y bar. Here x bar, we are going to take this horizontal. That means x bar is parallel to horizontal. For x bar, we know that this is the axis. Okay, this is the axis. For this axis, B, that is the distance we are going to take. For B, we know that this is smaller end. Okay, this is small. This end is larger end. Do you understand? This one is smaller end, this one is larger end, because this is 0, the vertical height. Here the vertical height is h. Do you understand? Here 0, here the vertical height is h. But we know that for x bar, we will take this leftmost line as the reference. This is the reference. So from here, we have to calculate the value x bar. Do you understand? Okay. To avoid the confusion, I just erase all these lines. Guys, this is small, where the vertical height is 0. This one, larger, where the vertical height is h. The leftmost line is the reference for the x bar. From that, I'm going to take the value x bar. Do you understand? So in terms of B, but it is going to be measured from the reference, that is smaller end. Smaller end means that will be 2 by 3 the distance. Okay, smaller end means that will be 2 by 3 the distance. Okay, so I hope you all understand the concept. I just erase this extra lines. So here, this is the leftmost line. That is the reference for x bar. And the x bar, I'm going to measure from this line. Okay, that will be the x bar. So the x bar equal, this is smaller end. From the smaller end means 2 by 3 the distance. Okay, this y bar or x bar, whatever. Okay, y bar or x bar. So here x bar, that is 2 by 3 the distance. Here the distance is b. So this will be 2 by 3 multiplied with b. That is x bar. Then y bar. Y bar, this is the axis, the vertical axis. And we know that this is the reference line. The bottommost line is the reference. Okay. Then here you can see for this vertical axis, here this is the larger dimension. When you consider the vertical, this is the larger because it has B. Do you understand? Then this will be the larger end. Here you can see in vertical point of view, this is very smaller, where vertical height is 0. So this is smaller end. But here we can say the y bar means we will take from this axis because this is the reference line. So from the larger end, here we are going to measure. Previously from smaller end, so 2 by 3, the distance. Here from larger end, we are going to measure. When larger end means that is 1 by 3 the distance. Here the distance is the vertical distance height. I hope you all understand. So I just erase the extra lines or marks in the diagram to avoid the confusion. Okay. So here, this is the reference of y bar. Okay. So here y bar is from larger end. Larger end 1 by 3 the distance. Here the distance is h. So 1 by 3 multiplied with h. Okay. So this you have to use for the triangle which is unsymmetrical about any axis. Okay. So now we discussed for rectangle, circle, and triangle. Okay. Next, trapezium. Okay. Here, the trapezium, one side it has the dimension A, another side it has the dimension B. The vertical height is h. Okay. Here A is the smaller side, B is the larger side. And then here you can see this is symmetry about the vertical axis. And then we know the bottommost line, that means this line, that is a reference for y bar calculation. Here there is no leftmost line, but the leftmost point is there. So the line passes through the leftmost point. That is the reference axis for x bar. Okay, this one. Here you can see first the area of the trapezium, that equal to, that is A, h multiplied with A plus B divided by 2. Okay, h is the vertical height, A and B, these are all the width of the two sides, smaller and larger, A plus B by 2. And then x bar. Here you can see, since it is symmetry about the vertical axis, the center of gravity will lie on this vertical axis only, anywhere it may be. So here, wherever the center of gravity lies on the vertical axis, the distance of center of gravity from the reference line of x bar, that means the leftmost line, that will be same. That will be equal to half of this distance. Actually, here from this point we can say it is A by 2, but the leftmost line is the reference here. So here x bar is from this side. So that will be half of the distance, half of the larger width, that is B by 2. And then y bar, that is also measured from this bottommost line as the reference. The center of gravity, that probably here, this vertical distance, that is y bar, this one is x bar, wherever the x bar is same. That y bar value for a trapezium is, can be calculated by using a formula h by 3 multiplied with b plus 2a divided by b plus a. Okay, so by using this formula from the bottommost reference line, we can calculate the value of y bar. Okay, then semicircle, which has r as the radius. Semicircle, it has the radius r, and we know that it makes an angle 180 degree since it is semicircle. Area, general formula for any circular sector like semicircle, quadrant, or any circular sector, we can say theta divided by 360 degree multiplied with pi r square. Here theta made by the semicircle is 180 degree. Okay, so area will be 180 degree divided by 360 multiplied with pi r square. So we can simplify this as 1 by 2, that is pi r square divided by 2, that is for the semicircle. Or simply we can say for circle it is pi r square, and then for semicircle it has half the area, so pi r square by 2. But this formula we can use for any circular sector, quadrant or any circular sector we can use. Okay, then it's x bar value. Same, this is also symmetry with respect to the vertical axis. So CG will lie on the vertical axis anywhere. Okay, like if you consider here, this is the bottommost line, that is reference of y bar. Here there is no leftmost line, but we can draw the leftmost, that means line through the leftmost point. That is the reference of x bar. From the x bar, you know, that means from the reference of x bar, this distance, that is x bar, and it is symmetry about the vertical axis. This value is same, and that equal to radius, because you know this value is radius. which is equal to x bar. So here x bar is radius. For this case, y bar, that will be measured from the reference axis, that is the bottommost line, and the value is 4r by 3 pi. This is from the base, not from this point. From this point means you got to take r minus 4r by 3 pi. So here y bar is 4r by 3 pi. Okay. This is y bar. If you need to measure y bar from this point O, okay, if you had taken that is from O, here I just mentioned this point as A, then this is from A. This one is y bar from O, or minus 4r by 3 pi. This also sometimes we will use. Then circular sector, it has the semi-cone angle alpha. Okay, r is the radius, alpha is the semi-cone angle. Actually, the angle made by the circular sector theta, that will be 2 times the alpha. Okay, so here the area of the circular sector, as we discussed in the previous case, the theta divided by 360 degree multiplied with pi r square. How much this total angle? This one, that is theta, which is equal to 2 times the alpha. That we got to substitute. For an example, if it is 90 degree, then 1 by 4th we will get for a quadrant. Then here y bar. Okay. The y bar value, the x bar value here, that means from here to here, that we can calculate by using triangle and symmetry principle, considering this off as the triangle, ignoring the curve. Okay. Mostly the x bar value for circular sector will be given. Okay. Otherwise, you can consider as this curve as the rectangle. Okay. By ignoring this curve, then we can consider with respect to the alpha and with respect to the vertical height by using tan theta, trigonometry use. Here y bar only we are going to discuss. The y bar from the point O, not from the base. Okay. Here the y bar formula is from the point O. Okay. This is from O. If you want from base, then r minus this value. That equal to 2 by 3 r sine alpha divided by alpha. Okay. If you need from point A, that is y bar from A. In case if this is G, this distance, they had given this value, that is 2 by 3 or sine alpha by alpha. Okay. So from this total means the total value, this is also radius. So radius minus this entire value, 2 by 3 or sine alpha divided by alpha. Okay. So we calculated trapezium, semicircle, and circular sector. Okay. Then volumes or solid bodies, center of gravity of solid bodies, hemisphere or sphere. First for sphere, which has the radius r. Okay. Hemisphere, both r is the radius here. Sphere, we know that the volume of the sphere, that is 4 by 3 pi r cube. Okay. And then here x bar calculation or y bar calculation of the sphere. For x bar, we know that we will take, this is the reference. Okay. This is the reference of x bar. And then this one, the bottommost line. Okay. That is the reference bar y bar. So whatever this distance, the x bar, that equal to radius. The y bar, okay, this one, that also equal to radius. So x bar, y bar is in terms of radius because center of gravity will be at the center of a sphere. Then for a hemisphere, the volume, it has only half the portion of the sphere. So the volume, this value divided by 2, okay, that is 4 by 3 pi r cube divided by 2. Then we will get the volume, that is 2 by 3 pi r cube. Okay. Then here, x bar. Since this is symmetry about the vertical axis, the x bar will lies on the vertical axis itself. And for x bar, we know that means the center of gravity will lies on the vertical axis itself. So the leftmost line, that is the reference of x bar. So from this, wherever the distance x bar will be same and equal to the radius, because this dimension is equal to radius. This is radius here. So here x bar is radius. Then y bar. Here we know that this line, that is the reference line of y bar calculation. And this is the distance of y bar. When you measured, if I have taken this point is A, this point is O. Okay, we got to mention from A only, the bottom line, bottommost line. That is the reference for y bar. That is 3r by 8. Okay, that is 3r by 8. This is from A. At the same time, we can say from the point O, that will be 5r by 8. That is r minus 3r by 8. This is from O. R minus 3r by 8. If you multiply, it will be 8r minus 3r by 8. So here the y bar, this is from point O. That will be 5r by 8. Okay. Actually, this is reference from that 3r by 8. Sometimes when you have to measure the semicircle from this side, that time it will be 5r by 8. Okay. Guys, with respect to the axis and the geometrical position, here we are measuring as x bar, y bar. In case the sphere is like this, do you understand? And here you can see it will be symmetry about this axis. That time, here x bar, that will be this distance. Okay. That will be from this point we have to measure. So that time here x bar is 5r by 8. And y bar, it is symmetry about this axis, horizontal axis. So the y bar is same, that equal to radius. So this x bar and y bar, that can be used vice versa with respect to the geometrical position of the given diagram. Do you understand? Then right circular cone, the volume of the cone, here it has the height h, r is the radius. This one is height and this one, that is radius. Okay. Volume of the sphere, that is volume of the right circular cone, 1/3 of the volume of sphere, cylinder. So that is 1 by 3 pi r square h, where pi r square h is the volume of cylinder. It is 1/3 of the volume of cylinder. Okay. So then x bar. Here also you know that the leftmost line or the line passes through the leftmost point. That is a reference of x bar. The bottommost line, that is the reference of y bar. Here you can see from the x bar, since this is also symmetry about the vertical axis, this x bar, that will be same and that equal to radius. Okay, only y bar here we are going to calculate. That also from the point O we can mention from the point A. But here, as per this geometry, the y bar is from A. Okay. If you had considered the geometry, the geometrical center, that the center of gravity is here, this will be y bar. Here the y bar is, that will be 1 by 4 h, or simply we can say h by 4. Or from point O, it will be 3 by 4 h. Okay, but actually y bar is, we have to taken from A. So for this geometry, h by 4, that is from the point A. In case if you want to measure from the point O, that will be 3 by 4 h from the point O. Okay. Then right circular cylinder. Here h is the height, d, that is diameter, r is the radius, and h as usual height. Okay. So volume of the right circular cylinder, that is pi r square h. Here x bar, y bar. This is symmetry about both the axes. This will be the reference axis for x bar calculation. So here x bar is also radius, and this one, that y bar, that is the vertical distance divided by 2. Vertical distance is h here. So h by 2. Okay. So x bar, that will be radius. Okay. For this case, x bar is radius, and y bar, the vertical distance, that is h divided by 2. Okay. So these are all the areas or volume we will use in the center of gravity calculations. Okay. So this is the overview of center of gravity. So for many areas and many volumes or solid bodies, we have discussed that the area or volume, x bar and y bar. Okay. I hope you all understand this video. For more videos in center of gravity, like numerical, especially, don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver. Okay. Thank you guys. Thanks for watching.